Hey guys, and welcome to the third episode of the Scripting 101 tutorial series. In this episode, we're going to be talking about two things, tables and loops, mostly because they're kind of related to each other in different ways. You need to use loops to kind of iterate through tables, and tables can be used in loops, etc. Right? But so let's go back to our regular go to service script service, add a script, right? Like we did in the last episode. We're going to use this for our testing and stuff, just because this is easier than the local scripts for right now. The first thing I'm going to go over is a thing called a while loop. And so it uses the keyword while, and you also, so it's sort of like, you have like if statements, right? You specify if, and then a boolean, and then the keyword then, and then the keyword end essentially specifies where the code that you run, if this is true, ends, right? So anything inside of this between then and end will run if true is true, which it is, so it will run, right? While loops are structured in kind of the same sort of way. So you do while true do. And instead of using then, you use do, but it's just basically the same thing. You can also use do on its end, on its own, which is pretty interesting. This essentially does the same sort of thing as if true then, where it's always going to run, but it creates a new scope level. So this can be useful if you just want to create a new scope level for something, but it's not used very often. But this is a while loop, right? And so what this is going to do, it's called a loop because it runs multiple times. It loops around, right? So print hello, print world. And one thing to note, if I run this, it's going to have issues. So I'm just going to run this to show you. I click run. You can see now I can't move around. It's like frozen for some reason, right? Eventually it'll show something in the output. It'll show like a script timeout error. Yeah, so this is something you don't want to do. Yeah, there we go. So you can see it says script timeout. But you can see it also has all of this, a lot of prints. And so what's going on here, right? So it's basically running this code over and over. So it prints hello, then it prints world, then it repeats this, right? And it repeats this until this boolean is false. And so this is just going to repeat forever because true is always going to be true. And having an infinite loop isn't a problem. That's not the problem here. The problem is that it's trying to run it all in a single frame. And so it can't finish processing this frame until this code finishes, but this code never finishes. So it just completely freezes everything, right? And so what you can do to fix that, if you want to have like an infinite loop like this, right? If you want to have a while true loop, what you can do to fix this whole script timeout error, this timeout is just saying it exhausted the allowed execution time. So like basically it's saying something's going wrong. Let's just crash. Let's just stop the loop so that way the script can continue and the game doesn't freeze anymore. What we can do to fix this is we can add a thing called a task.wait. There's also the deprecated wait, or I don't know if it's deprecated yet, but this is basically a better version of this. So just use task.wait. But this essentially is going to, if I just do this on its own, it'll, like without any arguments in here, without anything inside these parentheses, then it's going to essentially wait until the next frame. Because essentially, like with games, right, they have frame rendering, right? So every frame, it has to render all this information. And so when I actually like hit play or whatever, then as I'm moving around, it has to render each frame to like show what's visibly there. It also has to render physics each frame, and it does all kinds of physics calculations each frame. And that's what you see when you see like 60 frames per second. It's saying that like every second 60 frames are processed, right? This task.wait is essentially going to delay the code until the next frame happens, until the next frame starts. And so if we wait until the next frame happens between each time that we run this, it won't try and do this all in the same frame. And so that'll run just fine. And we can move around and everything works. It prints really fast and it's like spamming our output window, but it works, right? And it'll just keep going forever. You can also add a number in here to indicate the amount of seconds that you want to wait for. So if you add 10, it'll wait for 10 seconds. I'm going to do 1 because 10 is a lot. So I'm going to wait for 1 second between each time it prints these. So now you can see it'll do the same thing, but it'll put 1 second in between each time. And if you put nothing in here, the amount of time it's going to be waiting, Roblox usually, at most, will never usually go above 60 frames per second. And so essentially the time here is going to be 1/60th of a second, I believe, if you don't have anything inside the parentheses. So if I do 1 divided by 60, oh, not that. This is basically this amount of time. So if you do task.wait with nothing in the parentheses, it's going to wait for this amount of seconds or more. If it's like laggy, then it'll be longer. So you can't wait for smaller durations than that, so that's something to keep in mind. But you can wait for larger durations. But essentially what this is doing is it's waiting, it's repeatedly checking each frame. It's going to check how much time has passed since we started waiting, and it'll wait until a second has passed, and then it'll resume and it'll run this again, right? But effectively, the ultimate result is that it just waits 1 second. So that's a while loop. You can also change this Boolean condition. So you do local sum condition equals true while sum condition. So we can use variables here. And now if we change this variable, so I'm going to do like local sum counter equals 0, right? And I'm going to do, each time this runs, I'm going to do sum counter is going to be equal to sum counter plus 1. And so what this is doing is we're taking this number, which is currently 0, and we're setting it equal to itself plus 1. So we're updating this variable to this new value, and this new value uses this variable to create the new value. So it's going to be 0 plus 1, which is going to be 1. So then that 1 is going to go into here. And then when we run it again, it's going to be, this is going to be 1, and so there's going to be 1 plus 1, there's going to be 2. 2 is going to go in here. And so this is just going to increase it by 1 each time. There's also a shorthand notation for this, which is just plus equals. This does the same thing. So if we just do this, so this will just add, or not this right here. This will just add this amount to this variable. There's also minus equals, times equals, divided by equals. There's even concatenation equals, which doesn't apply for numbers. But so this is going to add 1 each time. And then what we can do, so right now sum condition is always going to be true. So this is just going to run forever and, you know, create the same issues before with the script timeout. But we can have a condition under which this turns false, which would then stop this while loop, right? And so we can do if sum counter is greater than 50, right? Greater than or equal to 50, then we can do sum condition equals false. So now each time we run this, we're also going to check, okay, is the counter greater than 50? And if it is, then we're going to essentially set this condition to false. And then the next time this while loop runs, it's going to be like, okay, because this essentially, it's like an if statement, right? But it's an if statement that runs over and over and over again, right? So the first time it runs, it's going to be like, okay, is sum condition true? Yes, it is. So let's run this. And it's going to be like, okay, is sum condition true? Yes, it is. So let's run this. And it'll do that 50 times or so until eventually sum condition is set to false because sum counter will be greater than 50, right? And then it'll be, okay, is sum condition true? And it'll be, okay, well, no, it's not, and so it won't run this, and then it'll go on down to here, right? And it'll continue in the code. So that's essentially how while loops work. So now, if I run this, I don't even need to put a task await in here because I know it's eventually going to terminate. It's going to end at some point because this will eventually get to greater than or equal to 50. And so it'll just print a bunch. Or maybe it won't. It doesn't actually print. I guess it should probably actually add a print. So print sum counter. We see it just printed 1 through 50, right? And it just did it immediately because it just did it all in one frame. If I added a task.wait, it won't do it immediately because it'll do it once per frame essentially, right? Now the next thing I'm going to get into is a thing called a for loop, which works similarly to essentially what we're doing here, right? Because what we're doing here, as opposed to like, you know, if we do while true, then it just goes on forever, right? But with this, we set it up to terminate after 50 iterations. There's a shorter way of doing that, which is using a for loop. So we could do for I. So I is like a variable, right? So you can name it whatever, right? You can name it that, or you can name it I equals, and I is like the standard way of doing it. It's short for index. For I equals, you can do 1, comma, 50, do. Print I. And since I is a variable, we can access that. So essentially what's going on here, so this is just like the syntax for it. This is just how you organize it. But essentially what's going on here is this first number is going to be the number that I starts at. This second number is going to be the number that I finishes at. And there's actually a hidden third number here, if I add 1 right there, that's going to be how much I changes each time this is ran. So the first time this runs, there's no condition, there's no if statement. It's not like a while loop. It's just going to say, okay, well, I mean, there kind of is an if statement, but it's going to define a new variable I, right? And it's going to set that equal to 1, and then it's going to run this code. And I can use I in this code, right? And then it's going to run it. It's going to go up here again, and it's going to increase I by 1. It's going to increase I by this amount right here, right? And then it'll run it again with I being 2. And then it'll run again with I being 3, all the way up to 50. And once it reaches 50, it'll stop and it won't run after 50. So it'll run 50, but it won't run after 50, as you can see here. And so in a sense, this is essentially the same thing as doing like local I equals like 1, right? While I is less than or equal to 50, do print I plus equals 1, right? Like that. These are both going to do the same thing. So I could run them both, and you can see how they both work. You can see they both print the exact same thing. They both just print 1 through 50. So this is basically just short for this, and essentially it gives you a counter variable that you can use. But the default for this third number is 1. So if you want it to only increase by 1 each time, you can just leave it with just these two numbers, and it'll start here and end here, increasing by 1 each time. But what you can also do, that's kind of interesting, is you can do 50 to 1 and decrease by 1 each time. So that'll count down from 50. So that can be useful for different things. You can increase by increments greater than 1, 2, and I can have it go down to 0 instead. So now it's counting by 5s down to 0. So that's for loops. That's a regular for loops. There's another kind of for loop that we'll get into later. But the next thing we're going to get into is tables. So a table is another type of value, right? So you have like numbers, you have strings, you have all those different types of values that you can put into variables. Tables are another type of value that you can put into a variable, right? So local sum table is equal to, I'm going to zoom in a little bit here. You use the curly brackets, an opening one and a closing one. That's just like shift and then the square brackets right next to the backspace key. This defines a new table, kind of like how, local sum string, that'll define a new string, right? These quotation marks. This defines a new table, and what you put inside of the table is sort of just like what defines like what the table is, right? So the simplest form of a table is just a list of items, a list of other values. So you can put like numbers, so you just separate them by commas, right? And the spaces don't matter. You can have spaces, you can have tabs. The white space doesn't matter. But this is essentially, it's a list of numbers, right? Now if I do print sum table, we run, see what that looks like, right? It prints this weird thing. You might not see this. If you don't see this thing with an expandable arrow, go over here to the top right and do. But you can click on this arrow and it'll expand it, and it'll show everything inside of that table. And what you can see here, so we have all these numbers that we put, right? And they show in the same order as we put them in here. But like on the right, we have those numbers. But on the left, we have just ordered numbers, just 1, 2, 3, 4, 5, 6, 7. And essentially what's going on here, these are the indices, and these are the values on the right. And so when we create a list-like table, and you could also call it an array. Other languages have data types called arrays, which function similarly to this. But in Roblox and in Lua and Luau, it's a little bit different because it actually specifies key value pairs for this array. And so when we add these items in, it's actually, each of these is being essentially assigned a number. So this is assigned the number 1, this is assigned the number 2, 3, 4, 5, right? And you can see those numbers here. Those are the keys, they're the indices, right? And these are the values that are assigned to those indices. But these values don't have to be numbers. They can be anything. They can be a combination of different things, right? I can run it and it'll print it all the same, but now you can see it has those different values, right? And another thing that's interesting is you could even add a table inside of this table with more things inside of it, right? And you can add tables inside of tables inside of tables, right? That's pretty cool, right? But there's also another way you can define these. If you do the same squiggly brackets, right? And if you go in the middle of it and press enter, it gives you a little bit more space. You can do it across, multiple lines or whatever, right? This will define the same sort of thing. But you can just, change how you organize it, but it works the same way, right? But what you can also do is you see you have these like key value pairs, right? 1 goes to 1, 2 goes to 2. Apparently they're mostly in order, which wasn't intentional. 8 goes to 7, 7 goes to 6, right? Each value is associated with a specific key, right? You can also specify your own keys that aren't necessarily numbers that are in order, right? You can do numbers for keys, right? So you can do 10 equals hello, right? And if you just specify 10 equals hello, then all you have is 10 equals hello. And in order to specify the key, you need to put brackets around it like this. Not always, but for numbers, you do need to put brackets around this. And you put equals to, and then hello. And so this is essentially defining a key value pair inside this table. And you can also define other types of values for the keys. So you could do hello, and you can set that equal to the string world, right? And you could add multiple values in here. So you could do comma, how equals are you, right? You can separate them by commas, but you can also separate them by semicolons, which is something I like to do when I'm doing tables like this. This sort of a table is structured more like what you would call a dictionary in other languages, like Python, because it's like if you think about like a dictionary, like an English dictionary, for example, right? You have word entries, and those word entries have meanings, right? So the words are like the keys, and the meanings are like the values, right? So essentially, a dictionary is a bunch of key value pairs. But a lot of times when I'm defining tables like this, when I'm making them like dictionaries, I'll use semicolons rather than commas, but that's just something I like to do. It doesn't really matter. It works the same way. You can see now it has two different values with two different keys. And with string keys, you don't need to include the brackets and quotation marks. If you just do like this will just assume that this is a string and this is a string. You can't do that on the right side. The values have to specify, so otherwise it doesn't know what type of value it's trying to set. But if you don't specify anything here, it'll assume this is a string key, and it works the exact same way. Except you can't do spaces like this, right? If I try and do that, it's going to have issues. But if I put it all in quotation marks and square brackets, then it works the same way. It works perfectly fine to do a space there, right? So that's just like some little syntax things. You can also do other weird things like true. I can put it in the brackets though. You could even put, what's kind of interesting is you could even do like a table set equal to a table. You could do weird stuff with it. So like 1, 2, 3, 4, 5, 6. I think it's going to have a hard time printing this. Yeah, so it just prints like the table ID, so the output window doesn't really know how to handle that. But you can have a table inside of a table as both the key and the value. So that's kind of interesting. But now let's talk about how we can actually use this table, right? So local sum table is equal to, so we define some table, right? 1, 3, or 1, 5, hello, true, right? So we have this table, and then we can say, we can print the whole table like all together, right? But we can also access specific elements in the table. So some table, we can do brackets, and this will essentially index the table, and we specify the key that goes with the value that we want. So if we want to access this hello, we would specify the key 3, because that's the third number, that's the third value provided when we defined it, right? So for print sum table 3, it's going to be hello. Other languages, just a quick note, other languages, so in Lua, it starts with 1, so it goes 1, 2, 3, 4. In other languages, it starts with 0, so it would be like 0, 1, 2, so this would be 2 instead of 3. But in Lua, it starts with 1, which is a little bit unusual for programming languages. But yeah, so that's how we access a specific value inside of this. And the same thing goes for like if you have a table defined like a dictionary. You have hello equals world, right? Then you could do print sum table hello, right? And you know, I can specify like that just to show you it looks the same, right? It uses the same symbols. This will print world, right? It'll access the key hello, and it'll get the value world, right? And it works the same way if I remove these, just like before. See, it still finds the value world. And then when you have strings like these, string keys, you actually can do a period and just type hello like that, which is kind of interesting. So this will be the same thing as what I did before, but that only works for strings again. So if you have, you know, a boolean for whatever reason, I don't know why you'd want to do that, but if you did that, but you do need to, you can't do like dot true because then it assumes it's a string. But if I put brackets, then it gets the same value. And notice when you're using the brackets, you don't want to put the period, so you don't want to combine the two and do that, or that. It doesn't know what to do with that. But yeah, so that's how you access the values in the table. And now, using tables, we can combine tables with loops in order to loop through a table, in order to iterate through the table's values. So you can do like local sum table equals, or like local attendees. Like say like you have like an event or something. You have a bunch of attendees for that event. You could have Jill, Bob, Joe. I don't know, right? You have a bunch of names in here. And maybe these are like players, so maybe you have like player names or player objects instead of these random names. But so you have this list of the names of the attendee names, and say you wanted to do something for each of those attendees. Like maybe you want to give them a specific reward for attending the event, for participating in like some in-game event or something, right? You can iterate through each of these values and do the same thing for each of them using a for loop, but it's a different kind of for loop from before. Rather than doing like for I equals 1 comma 5 to, or what we could do is do for I equals 1 comma 3 and then do like print attendees I, right? And this will just print all of them. But the reason it does that is because we start at 1 and end at 3. And so it'll go 1, 2, 3, and it just happens to line up. If we run that, it'll print all 3 of the names. If we change this to 4, then suddenly it gets nil because it's trying to access the 4th value in this table, but there's no 4th value, so it just gets nil. You could also do a hashtag and do the number of attendees. And so this is going to be, this is essentially taking the table and it's saying, okay, how many elements are in the table? This only works if the elements are specified with ordered number keys. If you have like a dictionary sort of a table, then this won't necessarily be accurate. It'll only include the ordered numbered keys. But this, since I'm using like an array, then this value will become 3 because there's 3 elements in it, right? So we can see it does the same thing. And now if I change the length of this list, right, then it'll update the loop to match. And it'll still print all 4 of them. But there's another way you can do this, where you can do for I comma v in attendees. You can also do for k comma v. These are both of them just variables, right? So you can name these whatever you want to name them. I comma v and k comma v are both common things. You could also do like, you also might see like underscore, which is just like if you're not using the index, then if you're not using this one, then sometimes people will do that just as like a placeholder. But essentially what's going on here is, so we specify the table object here. So in this table, and then this is essentially, this is the key, this is the value. So we're gonna iterate through this table, right? And we're gonna run this, anything inside here, for however many elements are in this table. And for each element, there's going to be a key and there's going to be a value. And this is where we get those the key and value pairs, right? So if we do print k comma v, it's going to print the key and then print the value for each of these, right? And so it's going to run this over and over for each of these elements. And so it does the same thing, except now it has the keys in front of the values. And so I can also change this, right? Sum table. I can do like a dictionary, update it down there. And I can do, John equals true, Jill equals true, Joe equals false. I don't know why I'm using so many J names, but so this could be like attendance chart, right? Who attended, who didn't, right? So you have a list of all the different players or all the different people, and you set them to booleans to indicate who attended and who didn't. So now I can iterate through that and I can print all those. I can also do an if statement inside of here, right? I can do if value is equal to true, then I can print k, print the name of the specific attendee, right? So that will only print the values from here where their values, it'll only print the keys from here where the values are true. So that's pretty interesting. You also can't have 2 keys be the same. So you can have John equals true and then John equals false. You can see it's giving me an error because I'm trying to define the same key for 2 different values. And then there's one more thing I want to go over really quick. If you notice here, this might look, if you've ever like seen for loops like this before, this might look a little bit different than you used to. You might have seen in the past pairs like this. And essentially, there's also like I pairs. And what these are doing, so pairs is designed for dictionary structured tables. So when you have, specific key value pairs, and the keys are usually strings, but not always, then pairs is just going to loop through those pairs, right? And it's not necessarily designed to loop through, so if you had like, if your table is defined, like, every numbers, random values, right? If it was defined like an array, it's not necessarily, pairs isn't necessarily going to loop through these in the right order. It might. I think it loops through them in the order that they're added, if I'm not mistaken, but that could be wrong. But it's not guaranteed to loop through them in the right order, from what I've heard. But iPairs is. So iPairs is designed for array structure tables. Pairs is designed for dictionary structure tables. And if you use neither, it's called generalized iteration, which essentially is like the best of both worlds. This is a relatively new thing that Roblox added to the modified version of Lua, which is Luau, right? And what this does is it will loop through numbered keys in order, and it will also loop through key value pairs. So this is like, so if I have like this table, right? And it's, I have 1 equals hello, and I have 2 equals my name is, 3 equals Billy, right? Something random. Then I have other things, hello equals world, right? So I have like ordered numbers, and then I also have key value pairs of like with keys other than ordered numbers, right? If I do generalized iteration, it's going to loop through both of them. Oh yeah, okay. So if I get rid of this, if I just do print k, v, you can see it loops through all of them, but it does the numbers in the correct order. But it'll also loop through other things. And the iPairs, another thing to consider, if I did iPairs again, it will skip anything that's not an ordered number. So now you can see it doesn't loop through the hello key. And if I have like gaps in the numbers, yay, right? If I have some gap in the numbers. So if I skip 4, right now the key 4 is set to nil because there's nothing set to it, right? It doesn't exist. It's only going to go up to 3 because the numbers need to be in order, right? So the iPairs is going to go from 1, and then it's going to increase one each time until it finds one that doesn't exist. And so it's not going to, even if I have them like woohoo, right? It's not going to do these ones because there's no 4 key. And so it's going to see these as just not being part of an array table. But yeah, so it's a little bit confusing between like the pairs and iPairs. If I just do pairs, I think it will do the right order. Seems like it usually does. But I think there are cases where it won't. If you have like numbers like these. But if you're confused by all this, then just go with generalized iteration. They added generalized iteration because it makes it simpler. It just makes it easier to understand. And this will work for pretty much most cases. I have had cases where it's a little bit wonky, mostly with like type definitions, which we'll get into in a future episode. But in general, this generalized iteration, hence the name generalized iteration, will work for pretty much every case that you need it to. And then one last thing with tables before I finish this episode. I know this has been kind of a long episode, but one last quick thing with tables is you can modify, just like other variables, right? You can modify them as you go. So you have some tables set equal to like hello world my 5. I don't know. Some random list of values, or you could do a dictionary as well. It's the same thing, because this is essentially the same as defining the full sum table 1. You could just specify like this. It's the same sort of thing. This is just like a shorter way of specifying all of this. If I specified all the way up to the 4th value, those are basically the same thing. This is just a little bit shorter for specifically array tables. But well, I can modify these values as I go. So if I do print sum table, I can do sum table. I can change the first value. So if I index the first value, so that's going to be this hello, right? And if I were to print this, it would be hello. And then I can use the equals operator to set it equal to something else. I'll use the AI suggestion, goodbye. And then I have to print it again to show what changed, right? So print some table, it'll print it again, but it'll print it with the new values. So in the first one, it says hello world my 5, and the second one says goodbye world my 5. So it changed the first value. You can also do set equal to nil, and that will just effectively remove the first value. I guess it still shows it here, which is interesting. I guess it doesn't necessarily remove it and just defines it as nil. I don't know. Or maybe it's because this is defined like an array. If I did 4 equal to nil, what does that do? Yeah, so I think it's because it's defined as an array, and so it assumes that there has to be a 1 position. But because it assumes there's not going to be any gaps in the numbering. But if it was defined as a dictionary, then essentially setting the value equal to nil is going to remove it from the table effectively. But there's a better way to do that for array tables. You can use the function called table.remove. And so here what you do is you specify the table you want to remove something from, and then the position you want to remove. And so you separate those with commas. And these are called arguments. They're going into the function. I'll talk more about functions in a later episode, but essentially you specify the table, and then you specify the index that you want to remove. And so it's going to go over here. It's going to say, okay, 1, 2, 3. It's going to take this. It's going to remove it, and it's going to move everything over. It's going to shift this over. And so now this is going to be the new 3, and now there's going to be no 4, right? So I can show you how that looks. So in the first one, and versus the second one, we can see that my was removed, and then the 5 was shifted up 1 index. And then there's also table.insert. You do the same thing, specify the table that you want to insert to. And then you can specify nothing, and it'll insert, or you specify the value first, I guess. Specify the value, yay, and it'll insert a new value at the end of the table. So you can see, oh, I need to print it again. Print some table. You can see it does hello world my 5, and then it removes the my, and then it adds the yay. So now there's 4 elements again, but it added the yay at the end. You can also specify a specific location to add the yay. So I can do, you need to specify the number first, I believe. So if I insert at like 1, and then the value, then it's going to insert at the beginning rather than the end. And you can see insert at the beginning, and it pushed everything further down rather than adding it at the end. So that's pretty useful. You can add it randomly in the middle too as well, and it'll move everything after it. But that's different from doing some table 2 equals yay, which just directly replaces the second value with this new value, right? It doesn't it gets rid of this value in order to add this value. Hey guys, it's me from the future. As is typical, I have forgotten a topic. So just really quick before we end this episode. With loops, with any type of loop, if you have a for I equals loop, right? Yeah, sure, 23. With a for I equals loop, with a while loop of any kind, with a for I comma v loop, with any kind of loop, there's 2 different keywords that are really useful to know. I'll zoom in a bit. So I'll do with while true loops just because that would be easiest to show. So if we have while, I'll do like a variable up here, local counter, right, equals 1. While counter is less than or equal to 50. So this is the same setup we had before. Or better yet, I could do while true, so it'll go on forever, right? And then I'll do counter plus equals 1 to increase the counter by 1 each time this loop runs. And then I will say if counter is greater than or equal to 50, then, and I'll do this keyword break. And this is effectively going to be the same as what we had at the beginning, which was, if I remember correctly, it was like, I'll do counter 2 equals 1, and like while counter 2. Then we had like counter 2 plus equals 1. If, I think it was just like that. And in both of these I had, or in this one that I had like a print counter 2 or whatever, right? So this, if you remember what this did, this is just essentially going to loop. It's going to run everything here 50 times, because this counter is going to increase. It's going to start at 1, and it's going to increase by 1 each time. Because in this case, somewhere how I'm doing the print after the increase, and I'm starting at 1, it's going to start at 2, and then it's going to go up to 50, I believe. But But this is so I'm doing the same thing here, but except instead of doing a condition here, I'm using this keyword break. And what break does is essentially, if this ever runs in a loop, in any kind of loop, it'll just end the loop right there. And so I'll do, I'll put the counter at 0 just so I can start it at 1. So when we print counter, then the counter is going to be 0, then it's going to be 1. It's going to print the counter, and then it'll check this thing. It won't be greater than or equal to 50 yet. And it'll repeat this until counter is greater than or equal to 50. And then it'll break, which will just end the loop, right? So I'll do down here, print loop ended, right? I don't need to actually run it, but you see what I did there, right? So this is 1 all the way up to 50, and it says loop ended because we had this break. Even though this is a while true loop, it won't run forever because we have a break here. Another thing to note is that anything after this break won't run. Oh, well. You can see it's even giving me an error message because it says this won't run, right? I can move this down here and it won't give me an error message. But this won't run. This will run every time this prints, except for the very last time. Because the very last time it will have done the break. And so, yes, it won't run after the 50, right? So, this is a useful keyword to use if you ever want to end a loop. Let's say you want to end it early, or if you have a true loop where it'll go on forever, then you want to end it like at all, right? Then you can use a break. The other thing is, if you want to skip a specific iteration, say we wanted to count 1 through 50, but we didn't want to count, I don't know, the number 5, right? So I guess we do like, if counter is equal to 5, so before the print, right? Then we'll do continue. So this is another keyword. And what this is going to do is it's going to skip everything down here for this current iteration, and then it'll move on to the next iteration. So it's kind of like break in that nothing after this is going to run. So if this runs, and then whatever is after this isn't going to run, so we do like print something, right? Then it's giving me an error message because it's not going to run right there, right? Because that's right after the continue statement. But it will go to the next iteration. And so it won't end the loop, but it will end that iteration of the loop. So now it'll just essentially skip the number 5. Or it just will break because I never told it to stop. Well, that's awkward. So this is a great example of why you should, always either do a task.wait if you have an infinite loop, or make the loop not infinite. I'll make it not infinite. So I'll do if counter is greater than or equal to 50, then break end. So I'll do both continue and a break just to show you. So it'll go 1 all the way up to 4, and then it skips 5 because it goes here and it says, okay, well, counter equals 5, and so we run continue, and then it doesn't do this. It won't even check this, really, because it'll have done the continue, and so it'll skip everything after that continue. But so it'll skip 5, but then it'll run the rest all the way up to 50, at which point it breaks. Okay, this was a bit of a challenging topic, so feel free to ask questions in the comments if you have any questions. I hope you enjoyed this video. I hope it was informative. And I will see you guys next time.